and welcome, and in this video we are going to be solving polynomial inequalities. Now if you have not watched my video on solving quadratic inequalities, make sure you do that first because it's actually the exact same thing. All we need to do is make sure that everything is on one side of the inequality and 0 is on the other side, and then solve by factoring. This is the same for quadratic inequalities as it is for polynomial inequalities, and actually is the same for rational inequalities, which is what we're going to be covering a little bit later in a future topic. So what we do is we get everything on one side of the inequality, as we see that's already done for us, and then we are going to solve as if this were an equation at first. So I'm going to go ahead and factor this. If it's factorable, make sure that you factor it. And this problem it is, and it's factorable by grouping. So let me go ahead. I'm going to speed through that, factor by grouping, and get my zeros as if this were an equation. Okay, so we're here. I ended up factor by grouping. I could go a little bit further using differential squares. You know I'm going to keep using that, right? And then I set each factor equal to 0 and solve. So I got -2, -2/3, and +2/3 as my three solutions. Now that would be if it were an equation. This is an inequality though. So remember, the way that we do this is we're going to actually plot these zeros on a number line and set up a sign table to determine what our solutions actually are. Okay, so I have my solutions plotted on the number line, and notice that I actually filled those in with solid circles, full points. And that's because it's or equal to. Remember, if it's or equal to, you're going to fill that in with a solid circle. If it's not or equal to, it's going to be an open circle. Now the solid, remember, means that we actually can be that value. It's going to be included in our final answer, whereas if it was an open circle, it would be excluded from our final answer. And remember, this is where we actually set up a sign table. So I'm going to write each of my three factors on the left-hand side. And now what I do is I test values in each individual interval. This is actually why I have everything on one side and 0 on the other side of the inequality. Because now all we have to do is compare to 0. That's why it's called a sign table. Because all I really have to worry about is if my final product, in this case, since these are three factors multiplying, get me a positive number or a negative number. And in this particular example, we want to be greater than or equal to 0. Well, numbers that are greater than or equal to 0 are positive. So any of my positive intervals are going to be part of my final answer, and the negatives are going to not be part of my final answer. They're going to be excluded. So now I'm just going to pick numbers in each interval and test them. So for example, I need some number to the left of -2. That could be some number like -5. And if I plug -5 in for x here, I'm going to get -5 plus 2, that's negative. 3 times -5 plus 2 would also be negative. And 3 times -5 minus 2 would also be negative. And notice these three are multiplying each other. So I'd have a negative times a negative times a negative. That would result in the entire interval here being negative. So I want to be greater than or equal to 0. That's not going to be part of my final answer. And now I'm going to test a number in between -2 and -2/3. -1 seems like the obvious choice. And now I'm going to do the exact same thing. I'm going to plug in -1 in for x. -1 plus 2, well, that would be positive. 3 times -1 plus 2, well, that would be negative, right? And if I did 3 times -1 minus 2, that also would be negative. So I'd have a positive times a negative times a negative, and that would actually result into a positive interval. So this is actually going to be part of my final answer. I'll get to that in just a moment. Now I'll test some number in between -2/3 and 2/3. 0 would probably be the easiest option. And if I plug in 0 for x, I'm going to get 0 plus 2, which is positive, 0 plus 2, which is positive, and 0 minus 2, which is negative, which would result in a negative interval, because I'd have a positive times a negative, which results in a negative. Then from there, I can pick any number greater than 2/3. Let's like say something like 10. And if I plugged in 10, 10 plus 2 would be positive. 3 times 10 plus 2 would be positive. And 3 times 10 minus 2 would also be positive. And if I have a positive times a positive times a positive, this entire interval here is going to be positive. And this is when I look back at my original inequality. I want to be greater than or equal to 0, so I want the numbers to end up being positive. Well, that happens in two places. It happens in between -2 and -2/3, and it also happens to the right of -2/3, kind of continuing on forever in that direction. And this can kind of be a solution on a number line. And this is one way that you can write your final answer. we are going to be focused on interval notation because that is kind of the norm in higher level mathematics. So remember, interval notation is lower bound to upper bound. We use parentheses if we can be that number. We use brackets if we cannot be that number. Well, the solid circles are going to kind of help us here. I'm going from -2 to -2/3, so from -2 to -2/3. I can be either of those because it was or equal to 0, so I'm going to put brackets around each, and there's a whole nother solution set here, so I'm going to go ahead and use U for union, and it starts back up again when x is 2/3 included, and it goes forever to the right to positive infinity, and remember we can actually never be an infinity. And this would actually end up being our final answer in interval notation. Now I want to go over 2 more problems, but that's basically it. Now there are some special cases generally when we have a factor occur more than once, or if we end up with imaginary zeros. So I want to take a look at a couple more examples just to be safe. So let's say we had something like this, x to the 5th minus 29x to the 3rd plus 100x less than 0. Once again, everything is already on one side of the inequality with 0 on the other side. If that wasn't the case, make sure you first get everything on one side and 0 on the other side. And now what we're going to do is factor. So I'm actually going to go ahead and speed through and factor this. So notice here I had a 5th degree, I had a degree of 5, so I ended up with 5 zeros, and they all ended up being real. I first had to take out a greatest common factor of x, that way I was able to factor a little bit further. So I got 5 zeros here, so now I'm going to have to plot all those zeros on the number line and set up a sign table. Now quick note, these are real zeros. Those are the types of zeros we put on the number line. Now you can get imaginary zeros. You would just simply not plot those on a number line because basically what we're finding is when the graph is above or below the x-axis. So we're actually just plotting x-intercepts. Now remember, imaginary zeros are not x-intercepts, only real zeros are, which is why you would actually not plot those on the number line. You would still include all of the factors, you just wouldn't put those on the number line. So I'm going to go ahead and set up my sign table. And now that I set up my sign table, I can go ahead and start testing values. Now I'm going to speed through this part, but real quick, I do want to make note of something. Notice here I have 1, 2, 3, 4, 5, 6 intervals to test, and I have 5 real zeros. And if you looked at the previous problem, you ended up with 3 real zeros and 4 intervals to test. Notice that the number of intervals is always exactly 1 more than the number of real zeros. That's always going to be the case. So I'm going to go ahead and test these out, and if I'm looking at my inequality, I want to be less than 0, so I want negative numbers. I want negative signs. I want minus signs. And also, I did not fill in any of the circles on any of the zeros because it is not or equal to, so we are going to be excluding -5, -2, 0, 2, and 5 from our final answer with parentheses. So let's go ahead and jump right into this. So here is our sign table all worked out. I ended up with minus, plus, minus, plus, minus, plus. And you may notice that that was actually kind of a similar pattern to the previous problem where it alternated back and forth, back and forth. That is going to be a pattern that emerges quite often. Whether or not it starts with minus or plus really depends on the problem. And also, this pattern holds up for the most part. However, when a factor occurs more than once, so when we have multiplicity, that's when the pattern is not actually going to hold up. So be very careful. I highly recommend just powering through and using the sign table. You're going to be using one of these a lot once you get to calculus as well, when you start graphing polynomials, rationals, all sorts of functions by hand. It is going to be an extremely useful tool. But for now, we're just using it to solve inequalities. And as I can see, I wanted to be less than 0, which means I wanted all the negative intervals. And I end up with 3 of them. So I'm going to have 3 intervals in my final answer for interval notation. So notice it is negative from negative infinity all the way up to -5. So I'm going to have negative infinity up to -5. Both are excluded. Union, it is also negative from -2 to 0. So -2 to 0. And also from 2 to 5. So this would end up being my final answer. I use parentheses on everything. That is because it is not or equal to. We never include infinities or negative infinities in our interval notation. They always get parentheses, and since we cannot actually be 0, we do not include any of these zeros. So 2, -2, -5, all excluded. So that would be your final answer for this one. Let's take a look at one more, and spoiler alert, there's going to be multiplicity, so it's going to look a little bit different. All right, so let's take a look at this last problem. I'm going to jump right in. Everything's on one side of the inequality, zeros on the other side, so I'm going to jump right in and start factoring. Okay, so now I jumped right in, and notice we ended up with x plus 3 twice, which means that we have a multiplicity of 2 for the 0, -3. Now, I can't plot the same 0 twice, so I am only plotting -3 once, and that should make sense. That's just going to change what the graph ends up looking like. Now, I do need to list a factor of x plus 3 twice, and you can achieve it by writing x plus 3 actually twice, or you can have x plus 3 quantity squared in place of it. It's entirely up to you. And now I'm going to jump right into the sign table, and you're going to notice something a little bit different. So if I test a number like -10, I'm going to get -10 plus 3 is negative, -10 plus 3 is negative, and -10 minus 3 is negative, so this ends up getting me a negative. Then if I test some number like 0, I'm going to get 0 plus 3 is positive, 0 plus 3 is positive, and 0 minus 3 is negative, so this is also negative. And if I test some number larger than 3, something like 10, I get 10 plus 3 is positive, 10 plus 3 is positive, 10 minus 3 is positive, so this ends up being positive. And right away you should notice that the pattern did not hold up. Notice it did not alternate from minus plus. It was negative, it stayed negative, and then it became positive. So this is going to result in a slightly different type of problem. Now here we want it to be less than or equal to 0, so we want it to be negative. And that occurs in two intervals, from -infinity to -3, and from -3 to 3. However, it is included, so I actually would write my answer as a single interval from -infinity to +3. And I would include +3. The reason, it wouldn't make sense necessarily to write it as two intervals. If I did, it would look something like this. Notice, if you wrote it as two intervals, you're including -3 both times. Which, yes, that's technically true, but why would you split it up at -3 if you're including it in both places when you can just write it as one interval? So this would end up being our answer. Now, I do want to throw a hypothetical out there. Let's say it wasn't less than or equal to 0. It was strictly less than 0. Well, then these would just be open. They would not be closed, which means I actually wouldn't be able to include -3. If this was the case, I would actually need to write two intervals to make sure I exclude -3 and obviously +3 as well. If that was the case, then yes, I would have to write two intervals to make sure that I do not include -3. And that would be because it was not able to be equal to 0. However, in our original problem, it was or equal to 0, which means I could be 0, which means I could be -3, so I'd write it as one interval. Just be aware of those. Special cases like this do arise here and there. Just be aware and make sure you're using your best judgment. And that is solving polynomial inequalities. I hope the video was helpful. If there's any questions, please feel free to let me know, and I look forward to seeing you guys in the next video.